Hello class, these are our notes for graphing linear equations. So we're doing review again, and this is part 1 of graphing linear equations. So first we're looking at the slope formula. So slope measures the steepness of a line. And so if you're given 2 points, so let's just go over here and pick my pen. So given 2 points, and the points are xy ordered pairs. So we're going to call our first ordered pair x sub 1 comma y sub 1. We're going to call our second ordered pair x sub 2 comma y sub 2. So given 2 ordered pairs, our slope is going to be represented by the letter m, and that's going to be y sub 2 minus y sub 1 over x sub 2 minus x sub 1. So this again is an equation for slope, which is the measure of the steepness of a line. So now we're going to go ahead and try working out some problems by finding the slope. So you could also graph the points, and you could count the rise over run. And sometimes when we're talking about rise over run, we write a y and the rise just to let you know that it's y over x. But it's a measure of how much up and how much over that it takes to have a line. So like this is our rise part of it, and this is our run part of it. So how much up, how much over. So in this first one, when I'm finding slope, I want to first label my ordered pairs. So x1, y1, x2, y2, and then I want to substitute. So for y2, I'll write 2 minus my y1 is 12. Divided by x2 is 13 minus x1 is 7. So this is just substituting numbers in for letters. So 2 minus 12, that's going to be a negative 10. 13 minus 7 is 6. And then I want to leave this improper but reduce it. So when I reduce it, I'm going to divide the top and bottom by 2, so negative 5/3. So that means I go down 5 squares and then across 3. To get from one point to the next on the line. So next one, same strategy, x1, y1, x2, y2. So this should be something you already know. This shouldn't be brand new, but it is nice to kind of have that review and just have someone remind you of things and reactivate things in your brain that you might have forgotten. So y2 minus y1 is 2 minus 5. x2 minus x1 is going to be 8 minus negative 3, so negative 3, and then if I have a minus negative, remember that means we are adding here. So divided by 11, and that's my slope on the second one. All right, so let's go ahead and scroll down through here. So slope-intercept form of a line is y equals mx plus b. So linear equations have an x and a y like this that we can graph. X is to our first power. There's no weird stuff. There's no like square root on your x. There's no fraction with the x on the bottom. There's nothing weird like that. So slope-intercept form looks like this. Your m is your slope, and 0 comma b is the y-intercept. So y-intercept is the spot where your line crosses the y-axis. So now we're just going to work on identifying slope and y-intercept, and again, this is review. So my number being multiplied by the x is 3/4. That means my slope is going to be 3/4. And then at the end of my equation here, I have this negative 5, which means my y-intercept is 0 comma negative 5. So if I was going to write b equals, I'd write b equals negative 5. But my y-intercept is what they're asking me for. And remember, it is a spot where you're crossing the y-axis. It is a point. So 0, negative 5. So if here's my x, here's my y. 1, 2, 3, 4, 5. 0 comma negative 5 would be right here. It means I went over 0 for x and down 5 for y. So that point is 0 comma negative 5. So the y-intercept is an ordered pair. On the next one, in order to identify the slope and y-intercept, I first want to solve for y. So subtract 4x on both sides. And then y is equal to negative 4x plus 6. So my slope is the number being multiplied by x, so m is going to equal -4. And again, my y-intercept, and I'm going to abbreviate it again by writing y-int, is going to be 0,6. All right, 6 looks like it's already solved for y, but I have to do more work on number 5 again. So first we'll move our x part over. It's positive. We'll move it by subtracting it. That's going to zero it out on the left, and it's going to effectively move it to the right. I want to write this as -6x plus 10, because remember we want our x part first and then our y-intercept. And then when we divide by 2, remember we have to do the same thing on both sides, so I have to divide everything by 2. And so let's move this up a little bit. So y is equal to -3x plus 5. And that means my slope, the letter for slope is m, is going to be -3, and my y-intercept is 0,5. All right, this last one is already in slope-intercept form. It's already y equals, I've got an x part, I've got a number over here. So m equals -2, and my y-intercept is 0,8. So now we're going to actually practice graphing a little bit. So we've looked at what slope means. We've looked at how to identify y-intercept and slope, and now we're going to put it all together and graph. So here my slope is 3, and my y-intercept is 0,5. So I'm going to start at 0, -5. That's a point right here. And then my slope is 3. So slope of 3, so let's kind of look at that slope of 3 part. So slope is 3. I want to make that into a fraction by putting it over 1. And then remember, slope is always rise over run. So rise is my y direction. That's my vertical direction. So I want to go up 3 squares. And then the run is my x direction. That's my horizontal direction. So I want to go 1 to the right. And I'm moving up and right because they're both positive. So from this point, I already know is on my line. I'm going to go up 3 and then 1 to the right, up 3, 1 to the right, up 3, 1 to the right. So from this square right here, I'm counting up 1, 2, 3, and then over 1 to the right. If I wanted to count points in this direction, I have to continue that pattern, but I'm kind of working it backwards. So now I'm going down 3 and 1 to the left. And let's think about how if I have a -3 and I divide by a -1, well, negative divided by negative is still +3. So that still shows a +3 slope. And then I'm going to do the best I can on this tablet to connect. It's not a terrible line, not a perfect line. There we go. All right, on the next equation, let's see, we've got another linear equation. Remember, x is to the first power, it's not squared. I don't have a fraction with x in the bottom. There's nothing weird here. So my slope is going to equal a -2. And my y-intercept is going to be 0, -1. So the 0, -1 is really my starting place. A slope of -2 over 1. Well, the last one, remember we talked about how it's rise over run. Top number is our rise. That's our vertical change, but it's negative. So now I'm going to go down 2. Bottom number, our run, is our x direction. It's positive, so right. So down 2 and 1 to the right. So from the point that's already on the line, we count down 2, 1 to the right. And we're going to just keep making points to go to the other direction. We're going to change things up, and we're going to do 2 divided by -1, which makes sense because either one of these fractions we divide out. If we divide -2 by 1, we get -2. If we divide 2 by -1, we get -2. So same slope, just different. One is to the right of my y-axis, the other one's to the left, but they're all connecting on the same line. They all line up. And I'm going to do the best I can to draw a line again. If your lines are really and truly terrible, you can skip that part if you're nervous about getting it all messed up. Okay, next one, I have another slope. My slope is -3/5. Sorry about these dogs barking in the background. So I'm going to go down and right. I think somebody's dropping off a package. The +4 at the end means my y-intercept is 0, 4. So we're going to start it at 4, and then we're going to go down 3 and 5 to the right. Down 3 and 5 to the right. Or I could go up 3 and 5 left to get all the points on my line. All right, again, I probably could use a line tool, but trying to do this fast. M equals 2/3 is my slope, and then my y-intercept on this one is 0, 2. So we're starting up in the positives again. Y-intercepts are always on my y-axis. Remember, this means my x is 0 and my y is up 2. So I don't go right or left at all in the x direction because the x is 0. We're only going up 2. Let's erase that stuff so we can actually do our graph. So now my slope is 2/3, up 2, 3 to the right. So it means up and right. I guess we better put in our counting directions again. So that slope is the steepness of the line, and it shows how all those points are connected. All right, that one did not connect well at all. I'm going to blame it on the barking dogs in the background. All right, last two. So on this one, I only have y equals 4. So there's lots of different ways to look at graphing this. One way is that it crosses my y-axis. Another way is I could make a table. And this is often my students will call this a straight line. Well, these have all been straight lines so far, but when I look at these last two, it's horizontal or vertical lines. If I was going to make a table for this, my equation says nothing about x, so x could be whatever I want, but my y always has to be 4. So if I think about graphing these as ordered pairs, when I graph this first one, 0, 4, that means that my x is 0 and my y is 4. That's what that ordered pair means, which is right here. When I graph the next one, that one says 1, 4, so I go over 1 for x, up 4 for y. And then this last one, x is 2, y is 4, over 2 for x, up 4 for y. And I end up with a horizontal line. That line actually looks pretty good. When I have a horizontal line, if I think about counting from one point to the next, I don't go up at all. I'm just going across 0 each time, right? So it's like I don't go up, but I just go across 1 each time. So I could think of my slope as 0 over 1, which equals 0. And I often think about this as if I set a ball on this line, how would the ball roll on a perfectly flat horizontal line? And it would roll 0. So it has 0 slope. So my slope here is equal to 0. Last equation. And notice it does also fit that pattern. I told you it was going to cross the y-axis, and it crossed the y-axis. And that's a common mistake. People think that because it says y equals 4, and that y is a vertical axis, that my line will be vertical. But it crosses my axis, that's why. So like my y-axis is vertical, but my line is horizontal. So that's something important. And it might give you a clue on the next one. X equals -3. So this one is going to cross my x-axis at -3. So let's go ahead and make a table. My x would always be -3. My y could be like a 0, 1, 2 or a 1, 2, 3 again, whatever we want. Because it only has x in here, there's no y. All right, so x equals -3. So when I graph like this first one, remember we could take this and think of that as an ordered pair. That's like the ordered pair -3, 0. So -3 up 0. And then the next one is -3 up 1, -3 up 2. So I get a line that crosses my x-axis at -3. So my x-axis is this like horizontal line here, but x equals -3 is vertical. I could also think about it as being like everything is -3 away from that origin, right? It's moved -3 units in the x direction. So -3 units left of 0, because this is basically like a 0 on my x-axis right here. So another way to think about that. So these are the first part of our notes. I'm going to go ahead and stop sharing now. We'll do the other video in a second.